what about the idea, if you can't find a difference that's visible between cyborgs, robots, and humans, how will you decide this question? A very good segue into my next slide. This is a classical test by Alan Turing in 1950, where someone asked him what artificial intelligence is, or what will it be in the case of 1950. And he made up this little experiment. Interestingly, this was patterned after a parlor game in which people tried to decide where remote humans who were writing responses were either male or female. Alan Turing changed the game, and the game was as follows. You put a person in one room, well, let's say they're at a terminal. In those days, it would have been a teletype. And you put a computer in another room, and somewhere where the second human can't see who's who and where they are, this human attempts to interrogate the two entities that are remote and tries to decide which one of them is human. Alan Turing said that if this person in general can't do better than random, in other words, can't decide who is the human and who is the computer, then the computer will be declared to be artificially intelligent. Notice here that we're giving the computer some great advantages over the cyborg android case that we were talking about here. There's no speech, there's no hearing recognition, and you don't look at the entity. You simply communicate via text. The Watson who won in Jeopardy lately had some of these same advantages, I might add. So indeed, it's a very interesting question. What we will do when machines exist who can pass the Turing test as it is configured by Alan Turing, but can pass the Turing test, in fact, in person. A philosopher named Ken Hema a few years ago was at a conference with computer scientists and computer ethics, and he asked the question, how can you tell whether I am a robot or not? And some very interesting arguments ensued, and someone pulled out a knife, little pocket knife, and said, well, I can figure this out real fast. And that ended that philosophical conversation. All the way back in 1966, Joseph Weizenbaum wrote a program which he called Eliza, after Eliza Doolittle in the Pygmalion image. And this was a rather simple pattern matching program. And you would sit down at a terminal and converse with Eliza. So some of the dialogue goes, men are all alike. This is the human. And Eliza says, in what way? The person says, they're always bugging us about something or another. Eliza, can you think of a specific example? Well, my boyfriend made me came here. Your boyfriend made you come here? He says I'm depressed much of the time. I'm sorry to hear that you're depressed. It's true, I am unhappy. Do you think coming here will help you not being unhappy? Now that sounds like a fairly normal conversation. Now I've played with the original Eliza program. This is an extraordinarily good stretch. Eliza's usually not quite this good, but pretty good. Good enough, in fact, that Joseph Weizenbaum was horrified that his secretary asked Joseph to leave the room so the secretary could talk to Eliza. He found, in fact, that many people found this parody of Rogerian therapy, in fact, inviting and interesting. And his horror led him, and some other deeper thinking about this, led him to write this classic in computer ethics called Computer Power and Human Reason, in which he talks about what he believed at that time we should allow computers to do and we shouldn't allow computers to do, and the differences between the power of computers and what he characterized as human reason. There are many chatbots that have come after Eliza. One of the most accessible, you can just check this out on the web, is called Alice, for Artificial Linguistic Internet Computer Entity. And you can go and chit-chat with Alice. And if you haven't done this kind of thing, I recommend it. It's quite an interesting experience. And again, you will have runs of conversation that, like the Eliza excerpt we saw, are really rather unsettling because they're so good. And then you'll hit something that seems completely and totally bizarre, and you will have broken the Turing test. One of the things that happens in the Turing test is really that we talk about how long you can keep up a conversation and not know if it's a machine. And Alice is pretty good. There's a thing called the Loebner Prize that's given every year to the best chatbot, the chatbot that a group of experts believes does the best job in the Turing test. And David Levy won this award in 2009. You can check out the transcripts on the Loebner Prize website. Now, this David Levy is a really busy guy because he was winning this prize and does a lot of artificial intelligence research, but he also wrote this best-selling book called Love and Sex with Robots. And no, he isn't kidding. Levy predicted in this book that in a very short time that it would be routine to have sex with robot partners, and he also predicted that in 50 years we would be having marriages between robots and humans. Now, that may seem a little bizarre, but there are research scientists, roboticists, who are making android robots that are amazingly lifelike. In fact, not very far from this room at Osaka University, one of the top roboticists in the world, Professor Hiroshi Ishiguro, has a lab in which some of these remarkable machines are being developed. And that's the professor to the right, his android to the left. These labs are justly famous for androids that appear to be humans. The outward appearances are finely tuned. Behaviors are finely tuned. Just as an example, Professor Ishiguro and his researchers worked for years trying to get eye movements that were realistic, blinking. And when you are close to these robots, and you are closer than I am to most of you, it is remarkable how similar the behaviors are to humans. They can react to touch and to voice, and they can mimic human expressions. Again, the human is to the right, the android is to the left. And yes, he made one of these of himself. He was telling me about a month ago that he regularly uses his android. He parks the android in his Kyoto lab, and then from his Osaka lab, he remotely controls the robot and tells his graduate students what to do and advises them. He says he has not yet gotten both paid twice for being in both places, but he assures me that he's working on it. Now, he isn't merely trying to reduce his commuting time. These machines are actually used in quite serious and significant experiments. The professor and his students study human interactions between humans as well as human interactions with machines using these android robots. Professor Ishiguro is not the only person working on this. This is a face. Again, this is an artificial face. It's David Hansen is someone else. And if you're looking for YouTube videos of very interesting facial expression experiments where machines can automatically mimic humans, there are a couple of really good Hansen videos out there. And these faces show what we would, for all intents and purposes, look like emotions are being shown on the face. Now, that begs the question of whether the machines are having emotions. And some very unhuman-looking robots are being used to explore the idea that machines may be able someday to have what we seem to believe act like emotions, thoughts. This is a humanoid robot, not at all an android, called Kronos. And Kronos was built specifically to explore, to model how humans interact with the world, how humans move in response to stimuli, and also to try and model how the brain functions in the human mind. And again, there have been some remarkable small, suggestive, provocative results from Kronos and other similar experiments. And you might say, well, you know, machines, silicon, chips, what does that have to do with neurons? Well, it turns out that computer scientists and others, along with neurologists, have come up with a simplified model of the neurons we have in our wetware, and this can be done in hardware and software, and these artificial neurons can be joined by the millions into what's called a neural net. And again, experiments have shown some very encouraging and, in fact, productive in the financial world. They're used extensively to predict, for example, market fluctuations. To exhibit, again, what we would, if we saw the same behavior in humans, we would call it learning. And these neural nets allow machines to adapt to their experiences, I'm putting it in air quotes, and change their future behavior based on inputs that tell them what's going on now. So is that human learning? Well, it's not identical to human learning, but it's modeled on some of the same patterns. And in fact, you see here all sorts of academic disciplines, research areas that are being mined and worked on in an interdisciplinary fashion, such as you were talking about, Stuart, in order to explore how computer circuitry can, if not mimic, perhaps someday embody some of the same thought processes we have. Is this even possible? Well, is it possible to have something called a conscious machine? Machine consciousness is an active area of debate in philosophy. And people are going back and forth on this. I just got a paper accepted with a philosopher at my institution where we're talking about exactly this question: can a machine ever be conscious? Now, some computer scientists are allowing this philosophical debate to continue because they think they're already there. And if they aren't already there, they're certain they're going to be soon. Not all computer scientists agree, but there is progress being made. Interestingly, one of the hardest parts of this debate is not understanding what the machines do. Of course, we can see what the machines do. That's open for everyone to see in the code. What's the most difficult part of this debate is defining what human consciousness is. We don't have a really good handle on that. And we're not that terribly good at scientific introspection. Now, why do we build these kinds of machines? Notice that this is a different question from how we might build these machines, or whether it is possible to build these machines. This why question is one that Deborah Johnson, a computer ethicist, keeps pounding at whenever these topics come up. She said, whether you can do it or not, let's explore why.